Good morning, everyone. My name is Filippo Maganza, and I'm a software developer from Alpenite, an Italian software integrator company. In this section, I will present the basic principles of the Lynx architecture, describing for each of them why they are used and their main idea. The aim is then to provide a list of reusable architectural models and design patterns addressing specific requirements or scenarios. We start with a very general scenario, which is the development of a large software project with complex requirements. The microservice architectural pattern addresses these scenarios by breaking software into smaller and loosely coupled parts, each of which can be developed and managed by small dedicated teams. The question is then how we can divide the application into microservices. This problem is often not straightforward to solve, since there could be many possible organizations. However, there are two rules that help us deciding which organization to prefer. Let's zoom in a bit on these rules. Let's start with the bounded context. Can you go next slide, please? The bounded context rule refers to the coupling of service components and their data as single units with minimal dependencies. In the bottom, you can find an example which goes against this rule. As you can see, there are 4 microservices named A, B, C, and D, and many dependencies among them, represented with the arrows. The question we should ask ourselves to understand why this configuration is bad is, what if B changes? The typical answer is that we need to check whether C and D have been affected in a negative way by the changes of D. And this is usually a very time-consuming task, especially for a team which should not have much knowledge regarding C or D. Next slide, please. Next, we have the single responsibility principle, which states that each microservice should have only one reason to change. That is a single tightly coupled group of people representing a single narrowly defined business from which changes can originate from. As before, in the bottom, you have there is an example which violates this principle. In this case, there is a single microservice responsible for both search and the name identity recognition. And as you can see, there are 2 tightly coupled group of people from which changes can originate from. This time, the question we should ask ourselves to understand why this organization is bad is, what if people from information retrieval and natural language processing request changes simultaneously? Well, the probable answer is that developers should synchronize their work to some extent, implying a loss of time. Also, another problem is that by breaking this principle, we decrease the fault tolerance of the system. So we should avoid this situation. Next slide, please. Okay, this diagram shows how we organize the Lynx application into microservices and how these microservices interact with each other and with the external services. As you may notice, most of the dependencies involve the workflow manager component, which acts as an orchestrator of services, both internal and external, in order to achieve coarse-grained functionalities. This component, this kind of coarse-grained functionalities will be addressed in a next section of the presentation. Next slide, please. The requirement we now discussed is designing an interoperable web API. Interoperability here means that the API should easily integrate with different types of clients. With respect to this requirement, the REST architectural style defines a set of useful principles. These principles revolves around the notion of resource, which can be thought simply as a piece of information which is possibly subject to change. Then the basic principles that REST provides are resources must be uniquely identifiable through URLs. Clients can manipulate resources through their representations using the set of semantics specified by the HTTP protocol, get, post, put, delete, and so on. Each HTTP request must contain all the information necessary for the server to understand the request. This implies that server sessions are not permitted. Okay, next slide, please. A good documentation has often fundamental importance for our REST API. The OpenAPI is a description format for REST APIs, which is useful for different reasons. It helps structuring and analyzing the documentation. It can be easily interpreted by both human and computers. And last but not least, any document compliant with the document can be visualized and tested using Swagger UI. Hence, a web user interface for the REST API is provided out of the box together with the documentation. Next slide, please. This is a screenshot of the document, of the OpenAPI documentation of the document API of Lynx, visualized using Swagger UI. I forgot to mention that Swagger UI is a web application developed by the same company who developed also the standard, the OpenAPI standard. In the bottom of the screen, you can find both a link to the Lynx API portfolio and to the Swagger UI webpage, where you can, of course, download the code and test it by yourself. Next slide, please. In order to create a web API using a microservice architecture, it is often useful to decouple the exposed web interface from the underlying microservices. The API gateway pattern can be used to address this problem. The main idea is having a single component which acts as entry point of the system and routes requests to microservices accordingly to some logic. In the right, you can find an example which shows how we used this pattern in the Lynx project. You can see that the collection resource has many sub-resources, documents, top K, documents, question answering. Each of these sub-resources is provided by a different microservice. And without this pattern, with this API gateway pattern, it wouldn't be possible to have such an organization. Next slide, please. Using a microservice architecture, we often have to deal with the problem of managing business processes that stretch across the boundary of individual microservices. To address this problem, Lynx uses the service orchestration technique, which consists of a central brain that drives the business processes, much like the conductor in an orchestra. The Lynx component responsible of service orchestration is the workflow manager. And the fundamental business process it orchestrates is the population workflows. As I said before, this component and this model will be explained in detail in one of the next section of the presentation. Okay, please, next slide. Sorry. To simplify integration of services into business processes and with the external world, we designed a model for the REST API of enrichment services, which are those services responsible of adding knowledge to documents, to existing documents. To this end, the enrichment interface consists of two contracts: the analysis API, which uses a post method, takes as input RDF Lynx document and an enrichment model identifier. The output is the given document enriched with the specified model. The other contract we have established is the model listing API, which uses a get method and outputs all the possible choices of models and their identifiers. Next slide, please. I move now to principles of the Lynx architecture, which are concerned with the security of the of the REST resources. One fundamental requirement in order to protect the REST resources is to establish a secure way of managing the authorization given by the source owner, like the user, to the client application. In Lynx, we have adopted the well-known OAuth protocol, which provides specific authorization flows for web application, desktop application, and third-party services. In between brackets, you can find some examples of this kind of clients for the Lynx project that we have addressed in the Lynx project. As an OAuth authorization server, Lynx uses Keycloak, an open source identity and access management solution. Next slide, please. One important requirement of Lynx is being able to define specific access control policies for fine-grained REST resources. One example of this is that each collection of documents should have its own access control policies. To this end, Lynx, to meet this requirement, Lynx adopts a centralized access control system based on Keycloak Authorization Services, which is a software module provided out of the box with the Keycloak server distribution. Okay, next slide, please. Okay, this diagram shows the internals of the Lynx access control system. As you can see, there are three main components: the API gateway, the Keycloak server, and the resource server, which in this case is the document manager. Furthermore, two human actors are shown: Alice, which represented some user, and the Lynx administrator. In this example, Alice asks for a get operation on collection 1 to 3. The API gateway receives the request and delegate to the Keycloak server the decision. The Keycloak server will use the data, authorization data it stores to decide and will send to the API gateway a positive or negative response. The API gateway will then act accordingly, and in case the response is positive, it will forward the request to the right microservice, in this case the workflow manager. The other actor, the administrator, can use the Keycloak, the Lynx administrator can use Keycloak administration console to manage authorization policies attached to resource. One important thing to mention is that with this kind of architecture for access control, it is needed to synchronize resources, or better, to align resources stored in Keycloak with the actual resources provided by microservices. So the Lynx implements this alignment using the API gateway. Okay, next slide, please. Okay, finally, this point summarizes the key aspects of the Lynx architecture that we have discussed so far, which are the microservice architectural pattern, the REST architectural style, the API gateway pattern, service orchestration, the enrichment interface, the OAuth protocol, and Keycloak authorization services applied to the Lynx access control system. That's all for this section. I will now leave the floor to my colleague Victor Mireles from Semantic Web Company. Thank you for the attention.